Information, chaos, and complexity. It appears as though the fragmentation of epistemology, represented by the multiplicity of scientific methods, is being counterbalanced by a growing homogeneity of ontology. Each field and discipline, regardless of department, is increasingly occupied with the analysis of large datasets and the statistical evaluation of correlations and patterns. All observed entities seem to exhibit that one common property of being represented and processed as a string of data or information. It appears almost outdated to speak of the laws of nature, as a broad systems theory approach is successively conquering the sciences. This approach is termed by some as cybernetics, the study of interconnected networks and feedback. Large-scale laws on the cosmos are difficult to arrive at if the objects they refer to, such as matter, energy, space, time, pertain to obscure entities which change their dynamics depending on the particular application of a certain theory. Interestingly enough, even theoretical physics appears now to entail a multitude of epistemic sects, such as string theorists and others, who are in constant debate about the metaphysical, mathematical superstructure that may unite their theories, despite there being no hope for experimental verification. It has become more common to construct models of complex systems and networks and then investigate various indicators, such as correlation, stability, feedback, regulation, information, and entropy. Perhaps the most important theory in biology, namely evolution, represents the oldest form of a modern systems theory prototype, where the emergence of new types by means of a complex interplay of elements is purported. In quantum mechanics, the notion of complex network interactions has led to the establishment of a highly sophisticated field of research. In general relativity, however, it seems that the introduction of thermodynamics, as the field that has incorporated the statistical systems approach, has led to a nihilistic cosmology. A universe that is approaching heat death, whilst also expanding, appears to be returning to a void of mere quantum fluctuations. From this void, the infinity of time enables any possible universe, such as ours, to randomly fluctuate into existence. This does away with any linear, circular, or otherwise comprehensible sense of time and leaves us with an entirely meaningless and chaotic universe. Even the laws of physics themselves need to be put in relation to the particular development of the cosmos. Each law may be evolved from ancestral dynamics and need not to be postulated as eternal truths of the world. The implications of this lead us to a scientific practice of model making and statistical evaluations of said models. This is what is inherently involved in the ad absurdum driving of the development of techniques, whose underlying data ontology consequently makes ever-increasing computational power systematically necessary. Most fields are occupied with computational science, not necessarily computer science, but thus have collectively turned into a monolith, driving computational complexity. The development of learning algorithms, or so-called AI, artificial intelligence, attempts to reduce hypothesis generation to a computational process. The seemingly abstract and unbiased statistical models are applied to large datasets in order to automate the process of research itself. It is becoming increasingly clear that the notion of nature and laws is being replaced by an effort to create functions which mainly focus on input and output, reducing epistemology to a form of logic, and semantics to syntax. This is further underlined by the attempts to supplement conventional logic with multi-model networks, potentially having the scope to handle a multi-valued structure of syntax instead of the conventionally binary encoding. The establishment of facts and knowledge seems to be driven by a belief in a rationally computable ultimate truth underlying nature, which is hoped will be processed by a possible general artificial intelligence once science has progressed far enough. The consummation of the intellect into a globally connected machine has implicitly become the principal objective of scientific research and development itself. Whether this aim is achievable or not remains to be seen. This was an excerpt from my upcoming book on the machine. Pre-order is available now on Amazon. If you want to support my work, pre-order my book and enjoy the other chapters I've written in it. See you next time.